So let's prove the theorem of geometric mean. So what does the theorem of geometric mean suggest? So in a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean. Remember this. Remember this word. It's much important. Is the geometric mean of the segments into which it is divided. So what do you mean by this statement? We have to prove that QS square, that is the perpendicular segment to the hypotenuse, QS square. So better write it. So QS square equals to PS into SR, into the segments into which it is divided. So the hypotenuse is being divided into segments PS and SR. Remember, PS and SR due to sorry, SQ, SQ, which is the perpendicular to the hypotenuse. So we have got QS square is equal to PS into SR. So we have to prove this statement or this equation, you can say. So we have to prove this. PS QS square is equal to PS into SR. So I will make a nice red color border to it. So we have to prove this. Now let's see how we will prove it. It's a simple proof for this. So as from the similarity of right angles, the theorem of similarity of right angles, we have PSQ, triangle PSQ similar to triangle QSR. So we have triangle PSQ similar to triangle QSR. From which theorem? The theorem of similarity of right angles. So you can check my other videos for the proof of similarity and of right angles. So let's write it. So we have triangle PSQ. This sign shows similar, and when there is an is equal to sign below this mark, it's a curve mark, and it shows that this is a congruent sign. So now we I just this curved line, two curves actually. So this suggests that something is similar to something. So we have triangle PSQ similar to triangle SQR or PQSR. So triangle QSR. So we have got this from similarity of right triangles. So this indicates right triangles. It's a right angle and this is triangle, or you can draw like this also, which also shows that it's a right angle. So anyways, so similarity of right angles, make it more precise. So similarity of right angles, we'll write this up. What? Right triangles. Oops. So this is our first statement, statement 1. Then now from we have got this information that triangle PSQ is similar to triangle QSR. So I can say, or we can say, that QS upon PS is equal to SQ upon SR. So it's equal to SQ upon SR from the properties of similar triangle, or properties of sides of similar triangle. So let's write it. So we have got QS, step 2, we have got QS upon PS, this side PS, equal to SR upon SQ, which is nothing but QS. So I will write directly QS equal to QS from property property of similar triangles. This is an triangle. So property, this is our PROPT I have written, that indicates the short form of property. So property of similar triangle. So now if I cross multiply these two ratios, then I will get QS into QS is equal to PS into SR. So let's write. So I will get the third step as QS into QS equals to SR into PS. Now QS into QS is nothing but QS square. So QS square is equal to SR into PS. Now let's check which statement we have to prove. We have to prove QS square is equal to PS into SR. And we have got the same QS square is equal to SR into PS. That is nothing but PS into SR. That is the property of multiplication. So we have finally proved the statement that QS square is equal to PS into SR. Hence side QS, I can't say side, length QS is the geometric mean of segment PS into SR. So is the geometric mean. So QS is the geometric mean of PS and SR. Thus we have proved this simple theorem. Thank you.